How frost heave impacts foundations. Beneath the surface of seemingly stable ground lies a powerful natural force that can quietly compromise the stability of buildings: frost heave. In colder climates, frost heave is a common but often underestimated threat to foundations. It can shift, crack, or even lift entire structures if not properly addressed. Understanding how frost heave works and how it affects foundations is essential for any engineer, architect, or homeowner concerned about building longevity in freezing conditions. What is frost heave? Frost heave occurs when water in the soil freezes and expands, causing the ground to push upward. Unlike solid materials, water expands about 9% when it turns into ice. When moisture within the soil freezes, especially in fine-grained soils like silts and clays, it forms ice lenses that lift the soil layer by layer. As this upward movement continues through the freezing season, it exerts force on any structure resting above. This uplift isn't just minor, it can generate several tons of pressure per square meter, enough to crack concrete or lift foundations out of alignment. Soil types most susceptible. Not all soils are equally prone to frost heave. Fine-grained soils, especially silts and loams, retain water more effectively than sands or gravels, making them ideal for ice lens formation. These soils draw water from lower layers through capillary action, feeding the freezing front as temperatures drop. Sandy or gravelly soils, with larger particles and better drainage, are less likely to hold moisture and therefore less susceptible. However, even in coarser soils, poor drainage or unusual climate conditions can lead to frost heave problems. Why foundations are at risk? When frost heave pushes up on the soil, it doesn't just disturb landscaping, it can compromise the foundation of a building. Shallow foundations like those under porches, garages, or small homes are especially vulnerable. Frost heave can cause uneven lifting, leading to cracks in walls, sloping floors, jammed doors and windows, and long-term structural instability. Even reinforced concrete can suffer damage when subjected to repeated cycles of heaving and thawing. Over time, this process can significantly degrade the foundation's performance. Frost depth and design considerations. Engineers deal with frost heave by designing foundations to extend below the frost line, the maximum depth where the ground freezes during winter. This depth varies by region, from as little as 12 inches in warmer areas to over 5 feet in northern climates. By placing the foundation beneath this frost line, it remains unaffected by freezing soil above. Local building codes often specify minimum depths based on historical climate data. In addition to depth, designers must also consider insulation and drainage to keep the soil around the foundation stable and dry. Prevention strategies in construction. Preventing frost heave starts with proper site preparation. This includes removing frost-susceptible soils and replacing them with well-draining material like sand or gravel. Adding insulation around the foundation, such as rigid foam boards, helps regulate soil temperatures and reduce frost penetration. Adequate drainage is also essential to keep groundwater away from the foundation zone. Techniques like sloping the ground away from the building, installing French drains, or using vapor barriers can all help control moisture and reduce the risk of frost heave. Real-world impacts and case examples. Frost heave has been responsible for costly damage in many cold regions. In Canada, northern U.S. states, and northern Europe, municipalities and homeowners alike report structural damage caused by improper frost protection. Roads, sidewalks, and small outbuildings often show the most visible effects: tilting, cracking, or rising above grade. In more severe cases, homes have required expensive underpinning or foundation replacement. These real-world examples underscore the importance of designing and building with frost in mind from the start. Long-term maintenance and monitoring. Even after construction, ongoing maintenance is important to prevent frost heave. Ensuring that drainage systems remain clear, grading remains effective, and soil around the home is compact and stable helps maintain foundation integrity. In regions with extreme winters, seasonal inspections can catch early signs of heaving, like shifting steps or cracks in masonry, before they escalate into major issues. Preventive landscaping techniques, such as planting low-water vegetation and avoiding excess irrigation near the foundation, can also support long-term performance. Why awareness matters. Frost heave might not be as dramatic as earthquakes or floods, but it is a slow-moving force that can cause just as much damage over time. By understanding how it works and designing accordingly, engineers and builders can protect structures from the hidden power of freezing ground. Whether you're building a home, a bridge, or a warehouse in a cold region, frost heave should always be part of the foundation conversation. Thanks for exploring the cold truth behind foundation stability here on Blueprint to Reality. If this breakdown helped you understand frost heave better, don't forget to like and subscribe for more deep dives into the forces that shape the structures around us. Stay grounded and stay curious.